Let's derive Newton's third law from the law of conservation of momentum. We're going the other way around over here. So we need to consider again two masses moving along a straight line colliding against each other. The velocity and hence the momentum of the two particle undergoes change, right? So after collision that happens. So you get to see it over here abundantly quite a few times, right? We get to see that. Okay, that example, that was pretty good. This example. So that's what we are looking at. Since there is no external force, delta P1 plus delta P2 should be equal to 0. Okay, so basically, let me continue over here. What we have is two objects with some velocity and stuff, and after the collision, the velocity changes. This is V1 and this is V2. So we need to mention few small facts. This is U1, U2. This is M2, M1, M2, and this is after collision and that's before collision. Wherever you can, you add diagrams, add. Even if you feel that it's not a big deal, but add. It helps. So this is before the collision and this is after the collision. Now, we know that by the law of conservation of momentum, what do we know? We know that delta P1 plus delta P2 should be equal to 0. If I rearrange this a bit, delta P1 should be equal to minus delta P2. And we divide delta T both sides, where delta T is duration of collision. So delta P1 by delta T is equal to minus delta P2 by delta T. This is nothing but rate of change of momentum of mass 1 is equal to rate of change of momentum of mass 2. Right? This is nothing but your rate of change of momentum. With respect to time, what does this give actually? Yes, force is defined as rate of change of momentum with respect to time. This is from Newton's first law. And therefore, force on M2 should be equal to force on M1. Sorry, not off. Force on M2 is equal to force on M1. That is, action should be equal to reaction. Okay, it's actually action of first object actually. The second object is reacting. Okay. Action should be equal to reaction. So he's hitting him and as a reaction, he's hitting back. So this is how you can prove your third law from conservation of momentum and second law. So yeah. And then this.